Hi guys, another series of coding videos starting here. So this series is going to be about the ongoing refactor that we're trying to do. It's the last few days I've been having a think of what it is that we're trying to achieve. So just to recap a little bit, for quite a long time, it's hard to even describe for how long, we have been attempting to refactor whatever is left of the C++ and the C# models, particularly the stuff under the Formatables namespace. And that has been a difficult thing to do, because what we're trying to do is what our approach was, which is a common approach I take a lot in programming. First, we just wanted to get something working. It doesn't really matter how you do it, just do it as quickly as possible. And then make sure that you can somehow validate that the thing is doing what you want it to do. So we managed to get the code generated, generate the code more or less as we wanted it to do, and that will happen very quickly. But then the second part of the exercise is to then build a conceptual model and to build a set of data structures that actually represent a sort of intuitive or logical way of modeling the entities that your code base is made up of. And that was not so easy. The overall architecture of it we conversed to it very quickly, but then the creation of a sort of a conceptual model that really kind of encapsulated all these notions was quite a hard thing to do. So just double check we are recording. We are. It's hard in a good way, really, because we've discovered a lot of things about the problem. We read a lot of research. We figured out a lot of stuff that people have been working on for a long time, which gave us a lot of insights as to the meaning of things in this domain. However, we're finding that at the moment we are struggling a bit with our refactor, because the problem could be defined as follows. We are trying to create metamodel entities to represent the instances of relationships and of entities that we've already got. And so for us to take as an example, imagine you have something like the include files in a file. Our approach was very, very straightforward. We basically created these sort of entities to represent the notions of include files. We created ways of computing the inclusions and so on. But we did all of that without really thinking at the metamodel level, which basically means that we have one way of doing it for C++, another way of doing it for C#, which is completely different. We don't really have the abstraction. So if you were to think of this in terms of maths, I guess, what we've done is we worked with the concrete types. What we should have done is we should have thought about the entities that sit above. Well, not so much mathematics, I guess, but more like model-driven engineering. And because we didn't do that, we ended up with lots and lots of special cases, and then now the code base is just not very maintainable. However, we did find the right way of modeling all these things. That's kind of what the logical physical space is. The difficulty is to take an existing code base and to try to move it to the new world, whilst at the same time making sure we don't break anything, and transitioning a very, very convoluted implementation to the clean implementation is actually really, really difficult, because normally this would not be the case. This is really how I normally approach all my projects. But the reason why this is very difficult is because on one side we have metamodel programming, and the other side we have model programming. In other words, for every time you think of something, you now have to think of the sort of the generalization of that particular case, and that is actually quite a thing that my brain is not really designed to do. Let's just look at a concrete example that will make this a bit clearer. At present, we're trying to compose paths. We're trying to create a way to generate a path. In the past, it was very easy. We just concatenated the elements of a path, and it was very straightforward. We just need the project bit of the path, and then the facet bit of the path, and then the file name, and then extension, and just join all these things together. Once you enter the metamodel world, now you have to think, what does a project path mean? And what does a folder like include or source mean? What are those things in terms of meta elements? So in that case, you have to think, well, actually, we need some kind of notion of segmentation. So the project is well, it's just a project path, so we need the notion of a project at the metamodel level. But then we need a notion of a partitioning of that space inside of the project. And then inside of that, then we need the notion of a facet, which you see here. Well, actually, this is the notion of a backhand, the notion of a facet. And inside of that, then we need the notions of the archetypes. And the archetypes then have relationships amongst themselves, which in the past were hard-coded, but now must be described via the logical physical model. So as you can see, all you've done is you've taken one concrete instance of something, and then now you're thinking about the generalization of these somethings, which is fine, is doable, except you're doing that while trying to refactor the code base. So it was clearly the case that we took too much on, really. We got to a point where we can't simultaneously refactor. The code base is too different. There's too much of an impedance mismatch between the end state of the code base and the current state, which basically means that every time we need to do something, we have to think. We have to have a lot of state in our brains to try to remember how the mappings work between this. It's almost like a graph of mappings, where you're thinking in terms of metamodel terms, but then that metamodel term then goes into a concrete aspect, it goes into another concrete aspect, it goes into another concrete aspect, all the way. Actually, sorry, I can hear some noise outside. If you bear with me a second, please. Sorry. So as you can imagine, these indirections make it really, really difficult. And because of that, I mean, I want to be clear that I don't think that there is a fundamental problem with the approach at the moment. It's just that you can clearly detect that we're slowing down over time. And the reason why we're slowing down over time is because the more we progress into the logical physical model, the more abstract things become. And up to now, we just about managed to navigate this abstract level of thinking, this very rarefied level of thinking. What is becoming clear, though, is that the more we try to finalize things, the more complicated things are getting. So, whilst thinking about all these things, suddenly it occurred to me that perhaps there's an easier way to do this, which is, what if we try to reduce the impedance mismatch between the code as it stands right now and the final destination of the code, the super abstract sort of final destination? And actually, that we've done that before. We've had some very similar situations. So, as an example, in the past, we've had a lot of elements in our models. They were modeling various different aspects of the pipeline. And in the end, we concluded that all those things should be, well, they should be divided into two very clear, well-defined models, the physical model and the logical model. And what we did is we moved a lot of stuff that was scattered all over the place, including the text model, the logical model, move all of that over to the physical model. Now, this is not the final destination of the physical model. We still don't like things like Metamodel Properties, for example. And there's still lots of duplication, such as extraction properties and all sorts of things here that are not quite right. What we gained by doing that, though, was that now it's very easy to think about these attributes in these modeling elements, because they're in the right places. Which means that whenever we need to do a change now, we can do it very, very quickly. So we've already done this in the past. We've already done these sort of intermediate refactorings where we've done something that wasn't really kind of the right thing, but it was half of the right thing, I guess. It just made things slightly easier to comprehend, to rationalize about, to think about, I guess. And we were trying to avoid having to do that for the formatables component of the logical or the text model, because we thought that we could just think it through. Now, clearly, we're not clever enough to think it through. It is just a very, very complex problem, especially for people that are not very good at really deep abstract thinking, like I'm not. And so, what we really need is to ease the barrier, to lower the barrier, really, to get us to a place where we can reduce the super complicated open-ended problem to an engineering problem. Because the thing that developers are really good at is engineering problems. If you give a developer a problem that could be broken down into small parts, any developer will get you to the end destination. Because we may not be able to do all of it conceptually. You may not be able to say, okay, I can't do this massive refactoring, but there's always something you can do right now, and there's always something else you can do tomorrow, and then something else you can do. And if you just stay the path, eventually you will go through all of it. And this is a sort of a general characteristic of any programmer. That's how we think. We think of small incremental changes over very, very long periods of time, and taking you to the right direction, rather than one big, large, massive conceptual change. That's not so much sort of a characteristic of the developers, really. We tend to think very concretely how to go from A to B, rather than massively long, sort of long-term visions of things. Because of course, if you think about it, it all goes down to abstraction. It's very easy to abstract yourself away from all the engineering problems, all the detail. You could easily say, oh yeah, all that needs to be done is this. But in reality, there's lots and lots of detail, and the detail is everything. So if you don't get the detail right, then you're not going to get there. So it's much more useful to break down things in small executable things than it is to have these long-term visions. I mean, don't take me wrong, visions are important, and I've always, I mean, Dogen is one big long vision, really. But I've always made sure we had a vision statement, we had ideas of where we're going, and so on. But I think vision is the long-term thing, and you know, you have to distinguish between that and the actual daily grind, the thing you need to do on a daily basis. And if you can't reduce your vision to a small number of steps that are executable, you are not going to get to the vision. So you must make sure that you can reduce everything, regardless of how complicated, whatever problem you're dealing with. It has to be reducible to a small number of steps that are implementable. So with all of that in mind and all of this said, what we're going to do now is we're going to take a bit of a detour. I know we've taken a few detours, but this is a detour that I think is going to help us. Instead of focusing on where we were, which was more metamodel work, trying to resolve the problems with the path, we're going to introduce a story this sprint, which is going to try to give us a path forward to put all the elements of these models in the right places. What we want to achieve is the following. We want to get rid of these formatables. We want to move all the data structures that exist here and all the transforms by hook or crook to the physical model, and in certain cases to the text model, although I don't think there's going to be many cases of that. There's a few cases I think they're going to have to go there. In some other cases on the logical model as well. It's not necessarily the case, we can't do that. We also want to keep the existing helper infrastructure. Now we know for sure the helpers are not the right way of doing things. We already have all of the designs for the PDM, the platform definition models and so on. But again, it's important not to have one big long refactor that never ends. You need somehow to have a close-ended task. And so even though you're going to do work that's actually going to be repeated and redundant in the end goal, it is important to do that work, the throwaway work, because it's scaffolding. You need the scaffolding in order to reach higher. Without the scaffolding, it's just your mind just can't get there. And eventually, when we do finish all this cleanup, and remember, this is not metamodel level cleanup, this is just low level, instance level cleanup, right? So we don't think there's going to be very, very complex problems that are going to be open-ended, that it's going to take us forever. And once we've done that, we will then try to merge the text models. Again, just using exactly the same approach we got here. Nothing special, literally just move this namespace here over to the text model, give it the right name such that this namespace does represent the backend rather than all the hackery we've got right now, and similarly for C#, so that we end up with a combined Dogen.text model, and we delete both of the text CPP and text.C#. At that point, we would have the code base in a much closer shape to the end goal, and it would make the work of trying to generalize all of that code much easier. The second benefit of that is that we're going to touch a lot of codes that we haven't touched in a while, particularly the computation of includes and dependencies and all that sort of stuff, which is exactly the kind of thing we need to remind ourselves of in order to refactor it with metamodel elements. So it also has that benefit. So I think that that's going to be this sort of the objective of this series of videos, really, describe this refactor. Now I may have to skip some bits because I think there's some bits that are going to be quite boring. What I'll try to do is I'll try to focus on the bits where I'm talking and explaining the approach, mainly because it helps me to think it through. One of my colleagues a long time ago, team leader actually, had this notion of a teddy bear effect, which was a lot of the times you don't really need to talk to another developer to get the developer to solve your problems. You actually need to talk to another developer to articulate your problem in a clear way, because once you do that, you realize what you don't understand about the problem, and you also realize the solutions to the problem. It's not just the fact that the other developer is going to give you different points of view, is that you yourself, by trying to explain something, will find different points of view. And given there's only me developing at the moment, this is the best we can get in terms of sort of obtaining a different perspective of a viewpoint. So that's what we're trying to do with this series of videos. Which means that when it comes down to the grind, the actual coding, I may have to skip a little bit, because I find that I'm a lot slower when I'm coding and trying to videoing things. It just doesn't seem to work out so clearly. So okay, let's just start then from the beginning. We're trying to create the analysis here for the Formatables refactor. So let's see. We'll just try to describe what we just said in words in a story here. We're finding difficult to map between the Metamodel Refactor and the existing codes. Not to film one here. Oh, by the way, one thing is I finally had to move to dia git, sadly, which now means that we have to deal with certain things that are not quite right, such as, for example, this grid here looks a bit weird. In fact, I wonder if it's possible not to view the grid. What would you call this thing? Rulers, I guess. Yes. Okay, this is good. I don't particularly like. I mean, I like the rulers, but I don't like the way they show up in Git now. They're just too tight, the elements, which makes it difficult to view. The other problem with this Git version from Git is that it doesn't seem to have Python support anymore, so you can't really use our coloring scripts. But it doesn't really matter, because our end goal is to move away from dia anyway. We're going to work on that once we've done with the refactorings. So we just have to deal with the slight problems we're going to have for now. Right, as we were, we're finding it difficult to map between the Metamodel refactor and the existing codes in the text models. The main reason is because there is such a large delta or impedance mismatch between the two. Ideally, we need the existing codes to be closer to the Metamodel refactor representation, so that we do not have hold so much state in the brain when refactoring. This also means we can reduce an open-ended problem to a series of well-defined software engineering tasks. Okay, so this kind of one thing we did forget to do. So, let's clearly have a clock open already. Let's have a look at what the clock is. Oh yes, okay. So yeah, the sprint. Well, to be fair, I think we can just continue this kind of more or less backlog grooming. So let's say keep everything. Right. So so let's just think about what we think. How are we going to break this very, very big problem into something smaller? Right. The first thing we need to do is we need to try to get the locator and the paths working. So that's going to be the task. This video will probably focus on that first. So as you can see here, we have a very, very simple way of creating paths, which is completely hard-coded. And this will also be a very good explanation for the kind of tasks that we have to do. If you think about this, this is really, in more ways than one, what we're discussing here is the gist of the model-driven approach. You start off by doing something, by hard-coding something, so that you understand the problem better, but then you have to generalize it. And now, what we're going to be doing here is kind of the half of that task. We're not actually going to fully generalize the code. We are not going to obviously hard-code it, because that's what we've done already. We kind of are trying to move away from the existing hard-coded code to something that's slightly less hard-coded. Not generalized, but just slightly less hard-coded. and also that fits, is more in keeping with the existing infrastructure. So for example, instead of these expanders, we use transforms, and you know, the what we've learned with all the terminology with model-driven engineering. So if you take locator as an example, first thing you notice is that half of the configuration for the locator is already available. So we already have all the facet directories, the postfixes, the archetypes, all this stuff. It's already available in the physical model because that was part of the work we did, was to try to tidy up all this sort of stuff. So it's already here. It's not exactly the same, but a part of it is there. The second aspect of it is, and now here you can see the hard coding. We, instead of having a notion of sort of parts and so on, we have things like an include directory, which is a very C++ specific thing. We have a source directory, again, same thing. And so what we need to do now is we need to take this locator configuration and move it to the physical model, because this all seems to be physical configuration. And then we need to re-implement the locator in terms of this plus whatever it is that we already have in the Metamodel Properties. And it's fine for us to just create types here. These are going to be deprecated types, really, just types just to get us going. It doesn't really matter. And it's also fine for us to copy and paste code from here with lots of hard coding. That's not a problem. We just want to move things away. So let's just try to work out what we need to do. So I'd say let's just put some notes here. So move locator configuration to physical model. We also need to reusing Metamodel Properties as required. Probably noticed that there is no music. Google copyright, as I mentioned in the other videos, Google copyright checks is just annoying me so much. I don't really care about monetization, but I don't really want to have to deal with videos that get banned just because I have a music on the background. So I just now there's no songs, which is another reason why I think we won't be able to record too much, because I really desperately need music when I'm coding. Helps me with concentration. So create a locator helper in text. No, in physical model, clearly. Then create a legacy full path transform, perhaps. So the legacy full path transform should now. So here we start to break with the existing model. So in the past, and now you hopefully will see what I mean by going halfway. So in the past, what did we do? We said, well, artifacts themselves know what path, well, the properties of the path that they need. So the idea would be that you would ask the artifact itself to say, what do you think your path should be? And the archetype would then call the locator on the right method. So for example, if I'm a header, I know I need to call make inclusion path for header. This approach kind of flips things backwards in a way. The reason why is because instead of being able to do a transform that applies across all the model, what we needed is to do we needed a two-step process. One step would be the generation of paths that requires going to the artifacts and talking to them. The second step will be the generation of the text of the archetype or the artifact. And that then meant, if I just, as an example, if I just jump over to say, let's just create a new area here. I'm just going to open up some templates. If I go up to build output, right, so if I open up a stitch template, and if I open up a mustache template, right, now then, I think we will need to locate, so stitch, poly, there we go, need to load this chap here. Right, so if I now jump over to this area here, let's call this Dogen templates, and if I just enable stitch mode here, although I do have to be careful to disable LSP mode, because Emacs starts to try to error check the templates, and that doesn't work so well. So this is a classic Dogen template for a text model to text transform. Now, really, if you think about it, a model to text transform should just convert from model to text, and that's kind of this bottom bit of the template. This is fine. That's what you want to see. You want to see something like, give me a model element. I mean, the casting is not so nice, but fine. You cast the model element, and then you start generating code. That's all nice and dandy. What's not so nice is that you also see this bit here where we have the inclusion dependencies. That's basically computing relationships between artifacts. That's one problem. Now if I take a slightly more evolved template, such as the class implementation, not only do I have that, but I also have actually this code has changed recently, so I think this is moved from the template. Oh yeah, of course. No, that's not where we're going to find what I'm looking for. You're going to find it, making things even more interesting, you're going to find them in the mustache templates. So if I take a mustache template, sort of like this one here, and you see in a minute why it is that we're trying to get rid of this approach. Right, this mustache template here, what it does is it merges with the stitch template. So if you think of Stitch as T4, like from .NET World, it's just a text template. And if you think of Mustache as in Mustache, the Mustache templates that are just replacements of keys and so on. We need both of them to generate the final C++ code for the model to text transform. And the reason why is because we're binding the archetype aspects of the template with the template, the templating part. And of these archetype aspects of it, some of them are just avoidable. As an example, these two, the inclusion path and the full path, are avoidable. If we had the right data structures to describe this, we wouldn't need to have code that does this, because the data structures will enable you to compose a full path and an inclusion path. And similarly, we also wouldn't have to have some kind of hack like we have this for the inclusion support type. And literally the only things here that are, of relevance, well, perhaps are these 3 bits here. And these 3 bits relate to, well, logging, because we need logging, and that's just basically commonality between all the text templates. We need a way of knowing where this template sits on logical physical space, and that's kind of it, really. These bits here are things that structurally we should be able to infer. Instead, what we've done is we flip it the other way around, and now we're asking every single text template about what do they think their full path should be, which is not ideal. So what we're going to do with this refactor is we're going to flip this the way that the refactor, the ultimate refactor, expects, which is it expects to be able to take a set of model elements and loop through these model elements, and for each of these model elements compute the full path. It also expects to be able to compute an inclusion path for it, and it also ultimately expects to be able to compute the inclusion dependencies for it. However, instead of doing one big long jump and saying, okay, fine, we're going to compute all of this on the Metamodel, which is what we're trying to do for the last 3 or 4 sprints, we're now going to say, first, let's just copy and paste all this stuff and create the transform, and make a really simple, absolutely linear transform. That's very, very dumb. It really is going to be the sum of all these functions here, plus one massive switch case. That's going to be saying, if you archetype X, do this. And once you've done that, then it will become much easier to create another non-legacy. So you can imagine you have the legacy transform, you have the new transform side by side, and you can literally just have an if statement that says, run the new transform, run the legacy transform, keep diffing until the diffs are 0, which is the approach we always take here in Dogen in terms of the development. That sounds very sensible. So the first target will obviously be this full path thing. Find a way to compute the full path from the outside world. Now, as I said, we are going to take dumbest possible approach, and that dumbest possible approach is going to be to say, if your archetype belongs to a set of archetypes, then do this. So once we have a locator, so let's go back to our story now that this is a bit clearer. Once you have the locator, create the locator helper, and then create a legacy full path transform in physical model. So have a set of simple functions that return the archetype kind, and you can see what I'm trying to do here. I'm going to try to simulate archetype kinds, which is these guys here. So we want to create the archetype kind. So create a set simple function, return the archetype kind given an archetype. Then use the kind to determine the locator function to call. So this is kind of a halfway house sort of approach. We don't really go all the way to the metamodel representation of an archetype kind, but we just literally get one massive switch statement that says, quite literally, if a dot name equals xyz, return kind a, or z, I don't know, something like that, and so on. This is going to be very, very boring, but very predictable. I mean, literally, you can now say this task will take X amount of time because you can multiply the number of archetypes by the number of things you need to do, lots of copy and pasting, and it's very, very simple from an engineering perspective. This does not require cleverness at all. That will solve, I believe, the full path problems. Simultaneously, also create all of the archetype kinds in the meta model. Well, actually, to be honest, let's just not do any meta model work for now. I was going to say we might as well just add the archetype kinds, but that's just going to complicate things, I think. We're going to think about them, but we're not actually going to create them just yet. Right, that's the first step. Then second step, well, in fact, to be honest, I suspect, let's just, I think what we need to do instead is, let's just say the following. I think this is the analysis here. We can clock can't see, oh yeah. We can clock the time against the analysis, but what we'll do is we'll start creating the stories. Move C++ locator into physical model. Now, hopefully, what you see is what's going on here. Control C, Control Q. Most interesting. Emacs seems to be not liking my current setup for some reason. So move C++ locator into physical model. This would have been a story if Emacs was not complaining. So let's just say we do that. Then, of course, we'd have a similar story for move the C# locator. You could just say as per C++ model. Okay, so that's another very simple story. So we move this guy, move the other guy, which is this guy here. There'll be a locator around here somewhere. You can see the hard coding that I was alluding to a second ago. There's the locator with its configuration. Then we shall tackle directive group. So move directive group generation to physical model. What? So we'll just move the directive group generation. I don't really like autocomplete on our files modes, if I'm honest. So let's just let's just disable it. It should really disable this in my config, but so then we will tackle this guy here, directive group, and the directive group will create all the directives, and these are basically the include directives or relative paths. We should probably consider renaming this to relative paths. Consider the role of parts in the directive groups. In other words, what we want to do is, in the future, of course, paths will be relative to parts. And so, for example, here we have different parts, some of them which require directive groups, such as the public headers part. And so if you can somehow find a way to bridge the gap between the two, it would be really good. Then we have inclusion. Move inclusion expanders, move inclusion into physical model. Right, so it's also going to be very, very simple. What we're going to do really is we're just going to move inclusion as is, as an inclusion expander. It's relying at the moment on the notion of the directory, but we're not going to use that, but we're going to use the dependencies builder, and we will just try to put all the dependencies, instead of where they are right now, we'll try to put them where they should have been in the first place, which is somewhere around here. If you see, there will be dependencies here. We need to just make sure the artifact has the dependencies where it should have. So that's also, again, something, just instead of having external data structures, use the existing ones. I mean, this is not, you must understand, I'm trying to make this sound absolutely trivial. We're still talking about quite a lot of work here. It's just that it's more predictable kind of work rather than the sort of open-ended work that you tend to do in meta-modeling. So that will take us to the dependencies, reduce, okay, that will take us to, so try to use artifacts to store dependencies. Right, so that's good. Then once we've done inclusion, we still have the header guards as well to worry about. So let's make sure that handle header guards as well. Okay, so that solved the header guard problem. We won't be needing an adapter anymore because there's nothing to adapt to. Okay, we are. So we have a set use of properties here that need to be moved. So let's say move assorted C++ properties into Metamodel Properties. And one thing that you probably should be noticing already is, from the way we're listing these stories, this is already a good thing, because we seem to be able to describe these things into nice little steps. One thing I don't particularly like about org mode is that at the moment it seems to really be wanting to give me a space when I start a new story. Perhaps I should really get used to that, but up to now we've started typing at the beginning of the line. So list of properties to move. Yeah, so that's very healthy that we are seeing self-contained small things that you can easily explain to another person. Streaming properties. So with the properties, create a transform to read these properties or add it to the existing Metamodel properties and so on. Bit of water. And there you are. Streaming properties will go to the Metamodel transform. We probably will need, that's already there. We probably will need C++ standards as well. These may need to be broken down into further stories, to be fair, because some of them are quite self-contained, like C++ standards and so on. The build files expander, that's very interesting. I didn't know that we're still doing that. Let's have a quick look at what that chap's doing. Build files expander. Okay, seems to be using the ODB properties. See if there's any comments on what this chapter is. No. It seems to be generating ODB targets, if I'm honest. Yes, so build files expander. These are ODB related targets, so I'm not entirely sure what we're going to do with these. Let's just put this in the list of Metamodel properties for now. Probably not the right place, but requires updating logical model with the properties and then creating transforms. However, okay, let's just delete that for now, but we know kind of what we need to do there. Test data properties we've already taken care of. C++ standard, add a guards, inclusion, dependency. Okay, fine. So I think that will take us there. And then the last bit, this will also be related to inclusion. So the last bit that we need to think about will of course be, for C++ at any rate, will be the helpers. So one big story here. Move helpers, and, well, move helper. Well, let's just say move helpers to text and physical models. So what we need to do is we need to say move helper properties to text model, and then we need to say move physical. No, move helpers as text transforms to text model. So we should try to refactor them to use the new text model transform interface. Now I was really not wanting to do this because this is most certainly just throwaway work. We're definitely not going to use helpers in the future, but like I said, more importantly, by trying not to do work that's going to be throwaway, we're actually slowing down the work that is important. So from now on, we're just going to forget about whether it's throwaway work or not. We're just going to try to make life easier. So ultimately, we just then have to do a cleanup. One thing we've forgotten is to look at C#. So C# would have similar things. Well, to be honest, we will just leave the helper properties there for C# as well. We already have a story for locator. And as you can see, C# model is so much easier. So I think what we can do is we're just going to piggyback here on the stories that we have got and say move assorted C++ and C# properties into Metamodel properties, and we'll just add C# ones here. There's not many of them, I don't think. That's already there. Attribute properties. And I think aspect properties, you might have that already there. And that is it. Then the rest is just helper stuff. And finally, we could say something like remove formatables So when it's interesting, you can't when all related all types have been moved, you can delete the formatables types in namespace. Okay, and at that point, then we just need to then say move, and this is going to be sadly it's going to be quite an annoying story, but it's going to be a long-winded story because it takes a while to move things around in Diam. So to move all these formatters over is going to be difficult, but so move all text transforms in C++ and C# models into text model. Rename namespaces to fit the topology. I'll probably use the word hierarchy, I think, of the logical physical space. And there you are. So now then, we're going to, with this, we're going to radically change this sprint now. What we're going to do now is we're going to say then the job of this sprint now is going to be reduce the impedance mismatch between the ultimate destination of the code base and its current state. And now we can say that's a much more sensible goal for this sprint. And we have all these stories here, and what we'll do is we're going to then say don't really want to deal with any story that's not focused. So the reason why I have sprint goals is just to help us filter stories. So what we want to see is we want to look at the stories in this sprint and say, oh, okay, that's actually in accordance with the sprint goal, or it isn't in accordance with the sprint goal. So what we're going to do is we're going to remove all the stories here that are not in accordance with the sprint goal. So from here, allow arbitrary physical containment, add descriptions to PMM elements, move analysis over org mode. So, well, to be honest, we could leave the analysis of org mode because we should really try to do a little bit of work on org mode every sprint. One annoying thing about copy and pasting org is that sometimes it pretends it leaves a blank space, but it doesn't. So we probably do need to continue to find MD papers to read, so that can stay. And all this stuff, dependencies to architect instances, nightly nursing, we probably need that because we always have some issues with nightly build. I must say, org mode copying and pasting is a bit painful at the moment. Add a validator, backend, deprecate, technical space, support for references, facet default. All these are stories that were in accordance with the previous sprint mission. See here the locator and physical model. Now you can see where we're trying to reduce these stories will also have to be removed. Will have to be refactored, sorry, because of course after this refactor the stories may not make sense. And I think we probably can get rid of all of this. Righty, now then, if we have a look at what we've got here, a few random spaces just to annoy us. Okay, so now then, we've moved a whole lot of stories over to the backlog, because they're no longer compliant to a sprint mission. And we could also start postponing some of these stories. So rename name to codec, that's fine. So we definitely are, well, I'm not going to actually postpone this story just yet. I'm almost 100% certain we're not going to have enough time this sprint to look at it, but we'll leave it until we do get to that point. I also think we're more or less done with this analysis, so we can close this story down. and this also, we're probably not going to get to it. Okay, the other thing I'd like to do as well is we now know for sure that we're not going to be, Dia is no longer our what should I say, Dia is no longer a strategic part of our work, and in fact the way things are going with Dia, I don't even think that's going to be very useful altogether. So I'm going to deprecate stories in the backlog that we got related to Dia, because I think we're just not going to have the manpower to do it, and you know, you should try to keep a back. I mean, of course, the backlog should be a sum of all ideas and so on. But having said that, you know, there's only some. Every time you put stuff in the backlog, it takes some cognitive capacity, right? So you want to keep stories in the backlog that are really kind of relevant. And if you start seeing things that is no longer in accordance with your vision, you should try to tie them up. So I think all these stories here that are related to Dia, trying to improve things with Dia, since Dia is no longer strategic. We are going to remove them because we're never really going to work on them. And as you can see, there's still a fair number of them. Again, we don't really want to do this either. So all these stories that and all these visions of Dia and JSON support, we need to sadly start deprecating them. Add conversion encoding support, we're not going to do that. Now we're not going to remove Dia altogether, so something like this, improvements to Dia model, we will leave that. We just don't going to invest any time making, for example, improving the integration of Dogen with Dia. These are the kind of things that it's no longer considered strategic, and that's why you need a vision, really, because the vision then helps you to filter out things that are just not useful in terms of where you want to go. Right, so one more pass. Stories with Dia on the title. Error in log files when reading the Dia model. What does that say? I think we still have that, so that's fine. Automatic Dia again. Okay, this is a really nice story, but I think, well, to be fair, this could probably be refactored in terms of automatic model update. So I'm going to take the word diagram because it could be used for any model, so that's fine. Allow placing types in global module in Dia. Again, I don't think we're going to need that anymore. Yeah, you have to be slightly aggressive when you're pruning of a backlog. If you want to keep a backlog that's actually useful. This is still potentially useful because we may want to use these things as an example. Okay, I think we've pruned it. And now what we can do is just search for Dia in general. It'll give you a lot of matches, but quick scan. Don't think we have anything obvious here. Sadly, we're going to have a lot of matches, so we can't really go through these very carefully, but well, that's probably enough for now. Okay, so now what we need to do is just create a rationale for this deprecation. Dia is no longer in the strategic, in the product vision for Dogen. Okay, and we just have to mark these as cancelled. This allows us to then, in the future, whenever we grep for the code base, to look for these stories. We know why we decided to cancel these stories. So the work is not lost as such, it's just no longer consuming cycles whenever we do a product backlog grooming, which is important. You must be able to do product backlog grooming without seeing lots of noise. And couple more. I do have to spend some time reconfiguring Emacs now, because there's quite a few things, as you do upgrades of course of packages and so on, behaviors change and then suddenly Emacs start doing things you don't really want to do. So life in a sort of a fast changing world. Right, I think that was fairly successful. I probably should clock the remainder of our time, which was from 16 past to backlog grooming. So 17 past. And I believe we finished with our backlog grooming. Okay, so what have we achieved with this video? It's probably enough for one video, I should think. About an hour. It's a bit of a boring video, I'm afraid, but this video was mainly to do with us trying to create, define what this sprint is going to be all about. It's a reflection of some of the ideas that we had regarding how to improve things with the refactor. As I say, we've been working on this refactor for a very long time. I mean, if you have a quick look at our release notes, I guess, I think you'd have to go, I'm not even sure really when we started thinking deeply about this. I would probably say, if we have a quick look at the sprints here, maybe 10 sprints probably, something like that, probably more than that. Not obvious from these release notes, but yeah, because we had the phase where we were trying to metamodel all things, which was a good thing, so that wasn't really directly related to the generation cleanup. But if you look at this, so extraction cleanup, annotations profile cleanup, and the generation metamodel cleanup has been here for a while. So I'm not sure, probably about 10 sprints we've been trying to do this refactoring. But like, again, as I say, to be fair, if you just say that it's 10 sprints to do a refactor, sounds like a very long-winded bad thing, but actually it's not that bad, because remember that it's not just about refactoring the code, it's about generating the logical model that's going to come with it, which basically means that you know, it's a thinking exercise. It's not just a trivial refactoring exercise. That's why it's just so complicated. Anyway, we finally seem to have a path to the next phase of this refactoring, and that path involves trying to simplify the existing. So let me just fix this for a second, because it's going to annoy me. And sadly, OCD people are easily annoyed. So this is one problem. It's good to be an OCD person if you want to be a developer, because you do spend a lot of time paying attention. In fact, to be honest, I don't think you can be a developer without being OCD about things, because half of the time developing really is paying attention to detail that most people don't really care about. That's kind of part of the job description, I'm afraid. The downside of it is that you're easily annoyed with things like spaces and placement and things like that. So as I was saying, the point of this sprint now is going to be to try to get us closer, in a closer state to where we want to be in terms of the refactor, so that we can actually do the refactor easier. But, you know, it just think of it as terms of jumping. Jumping a very, very large distance is very, very difficult, but somehow if you're able to make bridges in between, that will make each jump much smaller, and so that's what we're trying to do with this. Okay, I think it's going to be all for the first video, and I shall return with the next bit of work. Thanks for watching.